So in this video tutorial, what I'm going to do is talk about the periodic table of elements as put together by Mr. Mendeleev, who I've circled here in blue in the bottom left corner. So this is a little image of Mr. Mendeleev, who is a Russian scientist who lived in 1934 all the way to 1907 in Russia and put the periodic table of elements together the way we know it today. So the periodic table of elements is basically a pretty way to group elements together according to certain characteristics and properties. Now, the most obvious grouping is by atomic number. So this number here above each symbol which is a letter, is known as the atomic number. So atomic number. And the atomic number basically tells you how many protons you can find inside an element. And if this is a neutral atom, then it has the same number of protons and electrons. So 1 here for hydrogen means that there's 1 proton and 1 electron in a hydrogen atom. At the bottom, underneath the chemical symbol H, we have, I've circled in green, something called the atomic mass. So let's write that down over here, atomic mass. And this is a fancy way to describe how heavy the element is. Furthermore, we have inside each box, I'm going to circle this in blue now, the chemical symbol. So this in blue, let's go down here, this is chemical symbol. And each element has its own chemical symbol made up of either 1 or 2 letters. And if there's 2 letters, for example, helium here in the top right corner, helium has 2 letters, then the first letter is always capital and the second letter is always small case, lower case. So each element has either 1 or 2 letters in its chemical symbol. Now, I was saying before that each element has its own periodic number, atomic number, starting at 1, then going on to 2, and then 3, and then 4, 5, 6, 7, 8, 9, 10. And this goes on, and the pattern continues, as if you're reading a book from left to right, up to down. And all the elements are categorized in increasing order of atomic number, which in other words is increasing order of number of protons in the nucleus. So, if I were to take a look at hydrogen, I'm going to draw a picture of hydrogen here on the side. Hydrogen has 1 proton. I'm going to draw the protons in red, so it's got 1 proton. And it has no neutrons, and it has 1 electron. Electrons I'll draw in green. So orbiting around an orbit, we have a green electron flying around, and we label the electron E-1. So there's 1 proton, I'll write a P for proton, and in an orbit around the proton, around the nucleus, there's 1 electron. And in comparison now, if I take this helium element over here and I draw this one here, this guy here has 2 protons. He's got 2 protons, so let's put 2 protons like this. He's got some neutrons, which I'll draw in blue, some neutrons holding this together, and he's got also an orbital, and in his orbital he's got 2 electrons. And there's 2 electrons because in a stable neutral atom there are as many electrons as there are protons. So 2 protons, therefore 2 electrons. And so these are 2 drawings, 2 representations of the elements hydrogen and helium respectively. So there's another way to group the elements in this periodic table, and here's one of the ways that we can do this. So I'm going to highlight in light blue, this family over here. This over here is in blue. called the metals family. There's a continuation to this, and it goes over here. So it goes like this. I'm going to try to make sure not to get anything that doesn't belong there. PO is in there. SB is not. GE is not. Okay, so this over here is the metal family, and I'm going to write that down also in blue. So these guys here are, whoops, these guys here are metals. And metals are things that are shiny, things that are good at conducting electricity, so conducts electricity. It also conducts heat. So imagine, you make your frying pan out of metal, and the reason you make it out of metal is because when you put it on the stovetop, you want the heat from the stove to go into the food. So the metal from the frying pan is perfect for conducting heat. It allows heat to move. In red, I'm going to highlight the middle section here, which are called the transition metals. So these are not the same as the metals in blue, but they do share a name that sounds like them. So it's a type of metals, but we call them transition metals. Transition metals. And transition metals, for the most part, we're not going to be worried too much about this at this level, but it's fun to know that iron, cobalt, and nickel are three transition metals, the only three transition metals that are also ferromagnetic, which means if you bring a magnet next to it, they will be attracted to the magnet. And finally, not finally, but also, I'm going to highlight in green, on the side here, boron, silicon, there we go, these guys over here, Te. These green guys are called metalloids. So let's write that down. Metalloids, I'm going to write it in green. Metalloids. Metalloids are basically things that share properties with metals and also properties of nonmetals. So these things can have some properties similar to metals, but also can have properties similar to nonmetals. And so they could be shiny, but they could also not be shiny. They might conduct electricity, but some might not conduct electricity. So we say that they're metalloids because they have some metal properties and also some non-metal properties. So what's a non-metal? I'm going to highlight that in yellow. What are non-metals? Non-metals are the rest. It's all of these over here. All of these. Helium and also hydrogen. So hydrogen's floating all by himself in the top left corner. These are non-metals. I'm going to write that down in yellow. So these are, I'm going to write it here, non-metals. It's important to remember that non-metals doesn't mean that they're gases. And I say that because you can take a metal and you can heat it up enough for the metal to become a liquid and also to become a gas. Anything could be either solid, liquid, or gas.